Hi, I'm Meredith. I'm a dietitian. I'm not your dietitian, so please consult with your own personal health care provider before you make changes to your medications, your diet, your nutrition, um, your nutrition supplements, your lifestyle. So this video is a little bit of an update because I am continuing to study anhydroretinol as the probable cause of vitamin A toxicity instead of it being just the fact that we have too much vitamin A on board, even though that is a contributing factor. And I'll explain why a little bit more in this video. So this video is for anyone who has fatty liver disease for sure. It's also for anyone who has been an alcoholic in the past or is currently drinking. It's for anybody who has candida. It also would apply to anybody who has strange symptoms of vitamin A deficiency despite continuing to take vitamin A. So there's a competition going on in our bodies between anhydroretinol and retinol. And so they're competing. I'm going to explain that. So this is a liver cell, a hepatocyte. Here's the cell, and then there's a hepatic stellate cell, and that's where we store our vitamin A in the form of retinol esters. So these little things are it's retinol, the little kind of weird circle right here. It's retinol with a fat added to it. And what puts the fat on there is LRAT, but also some studies show that it could be DGAT, or which is kind of like the backup. If you don't have enough lecithin, then you can use DGAT, which normally helps you to add a fat to a triglyceride. So that's like a backup. And then I think that backup is tied up in making lipids because that happens during this anhydroretinol process. And that will be in a video that I'm recording very soon called Mitochondrial Madness. So you could use DGAT. And then there's one more, it's ACAT. And ACAT would be like the third backup to be able to try to make retinol esters out of your retinol. So, and both DGAT and ACAT, they bind via CoA. And so that's pantothenic acid. And I think that in this anhydroretinol pathway, we get deficient in pantothenic acid. So I think that our backups for LRAT are decreased. And so we're more dependent on LRAT, and that uses choline, and that can destroy your cell membranes, because if you're not eating it, then you take it from your cell membranes to be able to store retinol here in a lipid droplet inside a hepatic stellate cell. So how does it get into that stellate cell? Well, first, it's actually you get the retinol from the chylomicrons. So I got to go back a bit. You eat food, and in your digestive tract, you digest away a fat from the retinol, and then it's taken up into the cells and it's repackaged again into lipids. And I actually think that somewhat is on the brush border, but I'll go through that in another video. I'm going to really deep dive into the uptake. So once that retinol is repackaged into a chylomicron, it enters into your circulation through your lymph. So it gets into your lymph, and then it's passed in next to your heart, and then your heart pumps the chylomicron through the whole body so that your body gets a chance to use both fat and also uptake some retinol. And whatever is left over, it comes back to the liver on a chylomicron remnant. And then the liver's job is to store the vitamin A that wasn't taken up by the peripheral cells, and it's supposed to store it in the hepatic stellate cell. So when the retinol comes into the cell, it interacts with cellular retinol binding protein. And so the retinol gets stuck on there, and then it rides on this binding protein into the hepatic stellate cell, and then LRAT can work on it. And whenever we need to access vitamin A from our stellate cells, then another enzyme, retinol ester hydrolase, it removes the fat, and then the retinol gets back on cellular retinol binding protein and it's exported into the cell. Then your body makes another protein called retinol binding protein 4, and the vitamin A is put on to the RBP4, and then the RBP4 has a transthyretin molecule, which is where you carry your T4. So it's kind of like a storage for T4 in the blood, and they travel around together. So retinol and T4 travel around together in the blood. And so something interesting, a good connection is if you have very high T4 levels in your blood, you might ask your doctor to check your vitamin A because it also may be an issue. So, the transthyretin, it's bound to RBP4 because this makes it so you can't leak it through your kidneys. So it makes it a bigger molecule. And so RBP4, it carries vitamin A through the blood, and very high levels of RBP4 cause problems because it increases nitric oxide. And that's in a different video. And so it won't go on right there. So you can check out my other videos. I think that will actually, it would be in the nitric oxide. It's a Goldilocks nutrient video. So you can look for that one. Okay. So whenever, your RBP4 is going around in your blood, eventually it can come back to the liver and interact with STRA6. And that helps to bring any unused vitamin A back to the liver, because the liver is where we want to store it. It's like the safe house for it. So there's actually some studies about how the brain, the hypothalamus, senses vitamin A and helps to, in some way, upregulate enzymes and stuff involved in vitamin A metabolism or downregulate them based on how much vitamin A is in your blood carried on RBP4. So that's really interesting. Okay, so once the vitamin A on RBP4 goes into the blood and then it interacts with STRA6 in peripheral cells, then the retinol is dropped off, but it must be, put on CRPB, cellular retinol binding protein. So we want retinol bound. Retinol is an alcohol. It's a primary alcohol, it has this alcohol group right here. So we want it to be bound. We don't want alcohol freely floating around in our cells. So we have other things that buffer alcohol. There's a thing called PAPs, but PAPs in humans, there's no enzyme called a sulfotransferase that will bind retinol to PAPs. So that particular thing is only for alcohol and other metabolites, and I'll explain that probably in the mitochondrial madness video. So you can see that as the retinol is in the cell bound to cellular retinol binding protein, it moves through the cell and it actually is metabolized by these enzymes, and it still requires to be bound. So we need to have CRBP and RBP4 as our primary binders and carriers of retinol. So important. So then, yesterday, I was doing some research and I found this. Anhydroretinol binds to CRBP and RBP with a higher affinity, with a high affinity. So it says here, a common feature, I'm reading this for people who are just listening because, sometimes we don't look at the screen. A common feature in the physiology of retinoids is the use of intracellular and extracellular binding proteins, often specialized for particular retinoids for protection against oxidative degradation. That would be anhydroretinol, or other degradation products like, oxidative degradation. So I think technically anhydroretinol is like acid isomerization, so I can't say it's oxidative degradation, but it's for protection against oxidative degradation and for transport. All three retinoids tested bind to RBP of plasma, that's your RBP4, and to CRBP1, but the affinities of retinol and anhydroretinol are 10-fold higher than those of 14-HRR. And that's another metabolite. So it goes on to say that given these circumstances, competitive inhibition at the level of CRBP1 may explain the retinol anhydroretinol antagonism. So they're competitors. So you can see a dissociation constant means the smaller the number, the better it's bound. It doesn't want to get away from the binding protein. And anhydroretinol has a very small dissociation constant. And so you can see it's really good at stealing away our protection and our carrier of healthy retinol. So moving on. So what does that look like? So I made this red circle be anhydroretinol. So if anhydroretinol is tying up and binding to CRBP1 and RBP4, we got a problem. We got a big problem. And the problem is, one, you're not getting retinol into hepatic stellate cells, right? If anhydroretinol is binding to CRBP1, then there's no way it's going to move in to the hepatic stellate cell to be able to store retinol. Like if it doesn't have retinol in it, you can't get to LRAT, you can't store it. And interestingly, it makes me wonder if that's why alcoholics have no storage form of vitamin A in their liver when they've been drinking for a very long time, because we know that an alcohol plus an acid, and it could be acetic acid, that happens in our body all the time, an alcohol plus an acid equals anhydroretinol. So therefore, there is no retinol to store in the liver. Okay, so, and again, if anhydroretinol can bind to RBP4, then what's floating around in our bloodstream? And my question is, and I have to look into this still, is it possible that people who have normal serum levels of vitamin A, but still look like they're stuck in this pathway? Like I have a few friends and clients who have like liver disease, but their vitamin A levels look low. And so, you know, they say, oh, you're vitamin A deficient. Well, if anhydroretinol doesn't show up on a blood retinol test, and the serum retinol fluorescence at a different wavelength, which it does, then, and I'll show that in another video because can't put too much. I am thinking that those people who are very far down this pathway and have elevated liver enzymes, but very low levels of circulating vitamin A, perhaps their vitamin A is anhydroretinol. Again, got to go through how things are tested and look at all of that. So it's a hypothesis. Okay. The bad part about that is if you think, and I think, that my RBP4 has anhydroretinol on it, then that's what's being fed to my cells when I don't eat vitamin A. And anhydroretinol is not going to do the job that I need it to do. It's going to cause a pathogenic activation of pyruvate dehydrogenase complex, and it's going to cause massive reactive oxygen species. It's going to lead to multiple issues in the cell. Again, mitochondrial madness in a few days, maybe tomorrow, maybe today, I don't know. So another problem is if anhydroretinol is binding to our CRBP and tying it up, then the retinol levels in the cell go up. And remember, I said that retinol is considered to be a primary alcohol. It's an alcohol. That's why we have a binder for it, because we don't want alcohol floating around in the cell. So remember this from if you've watched my previous video. If you haven't, it's okay, I'll go over it. So studies have found that as long as there is an alcohol, ethanol, and an acid, you make anhydroretinol. And the key determinant here is it's going to be the alcohol, because the acid can help you to rehydrate anhydroretinol. So the problem is total amount of alcohol on board, and that alcohol plus the acid equals anhydroretinol. And they've done this at human body temperature, and we know that we make anhydroretinol inside lymphocytes. It's been studied. And also in animal studies, it shows that you can take retinol, you can inject it in animals, and then they make anhydroretinol. So it's happening. And for some people, it's happening in a large amount. And for some people, it's happening in a small amount, and they're able to recover. And so those of us with broken pathways, we're vulnerable. And that's what I'm saying, is this might not happen to everyone, but we're vulnerable if we have broken pathways. Okay, so I suggest that when anhydroretinol levels get high, and it's tying up the binding proteins in the cell, and CRBP is not available because of the competition from anhydroretinol, that retinol itself becomes the alcohol that's in the cell that's available to interact with acetic acid, and then whatever other retinol is there becomes anhydroretinol. And you're in a very bad place. This is where my Zoe is. So it's hard for me to actually look at my daughter and not think science. So I have to try very hard. Okay. Oh, I should say, why do I think that? She has all the signs of vitamin A deficiency, and her serum vitamin A is high. She has all the signs of vitamin A deficiency. She has candida in her stomach. It comes out through her G-tube hole. I finally got someone on board to help me treat it. So hoping this is going to get better. Okay. So let's look at the peripheral tissues. So if anhydroretinol is on RBP4, then guess what our cells get? Anhydroretinol. We don't want that guy. That guy is wreaking havoc on all of our cells. So what's the competitor? Retinol. Retinol competes with anhydroretinol. So you need fresh retinol. You need this from your diet. Now, I caution people who have candida or have been taking Saccharomyces boulardii, or maybe even have Aspergillus infections, because yeast, mold, they all can create alcohol. You might have to look up about the Aspergillus. I'm not 100% sure, but I'm pretty sure that these particular pathogens can cause alcohol. And so that might be the reason why we're so sick when we have mold toxicity and candida, and maybe we're trying to be smart and take the Saccharomyces boulardii to outcompete the candida, but Saccharomyces boulardii, it actually makes more alcohol than candida. So if you have a pathogenic overgrowth of that one, you're in the same problem. So if you have those, I would caution about getting that under control before you go super high on retinol. Just because I'm unsure about how much you're going to be turning retinol into anhydroretinol, because if you have this overgrowth inside your stomach of candida in particular, then you're going to end up having the alcohol in your stomach and the acid from your stomach changing your oral intake of retinol into anhydroretinol. And how you might know this is what I see with my daughter Zoe. When I give her a good source of vitamin A, say I give her cheese, and she eats it, she's sick. Within 4 hours, she's on the couch crying because she feels so bad. So I think it's a toxin to her. And so again, working on that gut health. However, if you do, one thing that is good to know, if you've been on chronic antihistamines your whole life, the chances of you having candida in your stomach is pretty high. So that's something to consider. I don't want to scare you, but I also want to inform. So maybe consult with a physician about what you can do to get rid of the candida, or research natural alternatives to that. It's not my area of expertise yet. So, all right, so we need fresh retinol because we want to be able to get rid of anhydroretinol. We want to outcompete it on cellular retinol binding protein. So eating 0 retinol per day. What if all your stored vitamin A in your CRBPs, remember you can't store it in your liver, but what if your stored vitamin A within the cells is anhydroretinol? Well, that's not good, right? And then a little anhydroretinol causes a massive metabolic issue, and then that could lead to more anhydroretinol. So, okay. So here are different metabolites of vitamin A. We have all-trans retinoic acid, retinol, anhydroretinol, 14-hydroxy-4, 14-retroretinol, or 14-HRR, 13-14-dihydroxyretinol, DHR, and REHYDRO. So REHYDRO is made with water and an acid catalyst. So acid's not the problem here. It might be a problem like in your gut. Like if you take apple cider vinegar, it has acetic acid, and if you have a problem with candida through your entire gut, that's alcohol, and acetic acid plus alcohol in your small intestine could mix together, and then you would have anhydroretinol. So anyway, but in the absence of alcohol, anhydroretinol comes REHYDRO, and it's not very active. It has less function. Some studies say like 7% of the function of retinol. Okay. So so after you make REHYDRO, though, it can be metabolized normally as long as you have plenty of NAD. You can make rehydroretinaldehyde, rehydroretinoic acid, and then you can metabolize it out of your body depending on your CYP enzyme activity. And in a shorter video about, I was talking about beta 13 apo, it's 13 anyway. So I was talking about that particular metabolite of retinoic acid, retinol, and retinaldehyde. Whenever you're on oxidative stress, you make this weird beta carotenol, and it actually inhibits CYP26. So that's not good. So you have to make sure that you mop up all the reactive oxygen species, or you're going to have a buildup of even rehydroretinol, and we don't want that. We want to go from anhydroretinol in the absence of alcohol to rehydroretinol. We want to get it out of our body because we want real retinol to do its actual job in the body. Okay, and then one study showed that if they injected rats with anhydroretinol, that they would actually make 14-hydroxy-4, 14-retroretinol. And so this is another possible way that the body can deal with anhydroretinol. So one thing to know is that anhydroretinol was very easily converted to rehydroretinol, but only in vitamin A deficient rats. And that makes sense, because if you have a lot of retinol on board and you don't have it bound up in your cellular retinol binding protein, remember retinol, I think, because it's a primary alcohol, it can become part of the catalyst to make anhydroretinol. Okay, so going low vitamin A at first, like there's many people who are doing a vitamin A free diet, going very low vitamin A at first might help you and make you feel better, but then in the long run, you run out of retinol. And that's a problem, because that pyruvate dehydrogenase complex, it's regulated 5-PKC delta, and it has to have retinol to work properly. So if you want to have long-standing health, you can't stay low retinol for very long. You'll get sicker. And that's the experience that people are telling me when they come to me to talk to me about their own personal experience with vitamin A detoxing. And I use quotations because I feel like it's not very much of a detox anymore. If we're doing it wrong, we're just toxifying. So, okay. So this is a short list of getting around this detour that I found just yesterday. One, you want to treat candida. You have to avoid Saccharomyces boulardii because, again, major maker of alcohol. Avoid alcohol altogether. Like, just don't drink. And I know that's hard because I'm an adult, but alcohol is not our friend if you're stuck in this pathway. You would want to take some vitamin E. Don't go crazy high dose above like the upper level. There's like an upper level. I think it's 1,500 milligrams or 1,000 IUs, or it might be switched around, but you don't want to go higher than that. You don't want to go higher probably than like 400 IUs, because without adequate vitamin C on board, you're not going to recycle the vitamin E. So look for a slow C supplement that's slowly absorbed into the body. You don't want to take regular vitamin C unless you cut it up into bits and take it over the day, because vitamin C can inhibit aldehyde dehydrogenase. And then that messes up your vitamin A metabolism. Coenzyme Q10 helps mop up all the reactive oxygen species that are occurring because of anhydroretinol pathogenically turning on pyruvate dehydrogenase complex. Pantothene, or pantothenic acid, because we want the acetic acid that's in our cells to become acetyl-CoA. We don't want acetic acid to be necessarily available in high amounts. I actually think my daughter has acetone poisoning, because when you don't have enough coenzyme A on board, you take your acetic acid and you turn it into acetone. And that makes you very sick and nauseated. And it would explain why she's been having a lot of those problems and headaches too. Pantothene, in some of the studies that I've seen, actually works better in the liver than pantothenic acid, but you might explore that on your own with your own healthcare provider to see which one is the best form for you. Again, you want to eat some fresh retinol daily, but not above the RDA. And again, caution if you have candida. And if it makes you feel bad, it's probably because you're just making anhydroretinol in your gut and then absorbing it. And I'm very sorry. You just got to get that candida to go away. Okay. I always like to say, fungus among us. Okay. So anyway, Epsom salt baths. So that will restore your sulfate. In this pathway, people are having a hard time going from sulfite to sulfate because they get a molybdenum, I always say that one wrong, deficiency. And so Epsom salt has magnesium sulfate in it. And so it absorbs into the body and helps restore sulfate levels. It's dark outside right now because last night there wasn't any hot water left for a bath. So I tried to take a cold bath with Epsom salt and it didn't work, because you have to like warm up the skin, I'm thinking, to help the magnesium sulfate get in. And so I didn't sleep, but that's my helper for sleeping. For you ladies out there, it's because when you increase sulfate, you make PAPs, and PAPs buffers estrogen in your blood. And unbuffered estradiol, if you don't buffer your estradiol, you can't move it through the blood adequately to get to your brain. And so if you have low estradiol in your brain, then you can't sleep. So there you go. Take an Epsom salt bath before you go to bed. So there's more tips at weekthereforestrong.com, but if you want quicker interaction, because honestly, I'm really, really bad about checking my email, really bad. So if you want quicker interaction, you could join the vitamin A toxicity support group, and you can tag me in a post, but everyone in there, it's such a good group of people encouraging each other and trying to help each other for the most part. So please join that group. All right. I think that's all I have for you for today. And I hope that this was helpful. And thanks for joining me on this crazy journey to like learn more and more about anhydroretinol. And I will see you in the next recording.